Before we move to the programming screencast of PageRank, I'll be telling you how can you draw graphs using NetworkX. I hope you are familiar with the NetworkX library. We have simulated it in the Joy 6 degrees of separation. So if you haven't gone through the videos of NetworkX, I'll recommend you to go through the videos of NetworkX first. So first of all, let me show you how can you draw graphs using NetworkX. So as and always, we'll be importing the concerned library. We'll be importing NetworkX here. So I'll write import NetworkX as NX. Next, I'll be showing you various graphs that are available in NetworkX. So first of all is the barbell graph. So I'll write NX dot barbell graph. And in this you need to supply two parameters. I'll supply 4 and 2. We'll be getting to know why I'm supplying these two parameters here. Then I'll write NX. I should initialize the G variable here as this so that I can draw it. Barbell underscore graph and the two parameters. So now I'll draw this graph. NX dot draw G. So as you can see, we have the two communities here. We have two communities which comprises of 4 nodes. So in this particular community we have 4 nodes, and in this particular community we have 4 nodes. So next, if I write 4 and 3, then what happens? Let's see. See, we have 4 nodes here, and in between we have 3 nodes. In this particular graph we wrote 2 and we had 2 nodes in between the two communities. So what does the first parameter represent here? It represents the number of nodes in a particular community, and the second parameter represents the number of nodes in between the two communities. So we will draw it again and you will get a clear idea of what is happening here. So this time I'll write 5 and 3 and then draw it. So 5 nodes here, and in between we have 3 nodes. So this is how a barbell graph works. Next, I'll be telling you some more graphs. Next, we'll be drawing a complete graph. So I'll write G is equal to NX dot complete underscore graph. And in this particular thing, you need to supply what are the number of nodes. So I'll just supply 4 here. Let me draw it. NX dot draw and G. So I have a complete graph and it comprises of 4 nodes. So those who don't know what is a complete graph, in a complete graph we have each node that is connected to its n-1 nodes. For example, if I pick this particular nodes, it should be connected to rest of the 3 nodes. So here I pick this node and it is connected to rest of the 3 nodes. So basically it is connected to the rest of the nodes except the node itself. That graph is called complete graph. So next, basically it has every possible edge that can be present in the graph except the parallel edges and the self loops. Next, what we need to do, I'll show you how can you draw a cycle graph. I'll write NX dot cycle graph, and in this also you need to supply what is the number of nodes here. So I'll write 5. Let me show you. Next, you write NX dot draw G. So we have a cycle of 5 nodes. So what next? There is another graph available in NetworkX, and that is ladder graph. So I'll write NX dot ladder underscore graph, and you supply the one parameter here, and let us see what does this parameter do. And NX dot draw capital G. So we supplied 5 here, and we have 5 nodes on each of its parallel edges. We have 5 nodes here and we have 5 nodes here. In this way, you can draw a ladder graph. Next is a path graph. So I'll write G is equal to nx dot path underscore graph and supply the number of nodes present in this path graph. I'll say 6. Nx dot draw capital G. So you have a simple path comprising of 6 nodes. Then I'll draw a star graph. So what we'll do nx dot star underscore graph. And then I supplied a parameter here. Let us find out what does this parameter do. And then let me draw this particular graph. So since you supplied 5 here, we have 5 nodes as the sink nodes. I hope you know that what is sink. It doesn't have any outgoing edge. So there is a hub node at the center of this star graph, and we have 5 nodes as the outer sinks. As the outer nodes, we have 1, 2, 3, 4 and 5 as the outer nodes, and we have 1 sink. So whatever parameter you supply here, that becomes the outer nodes, and there is 1 hub node. So in this particular graph, there will be n plus 1. There will be parameter plus 1 number of nodes. So if I supply 4 here, then there will be 5 nodes in the graph. 1 will be hub node and the 4 node, and there will be 4 outer nodes. So let me draw it again. So we have 4 outer nodes and we have 1 hub node here. So what next we need to do here is, next is we can draw a wheel graph also. So I'll just write G is equal to nx dot v underscore graph, and you supply 1 parameter here again. So we will draw this graph. So we have a wheel sort of thing. It is basically a 4 node graph, and it looks like a complete graph also. So it is a complete graph. So next we will do it for 5 nodes, and let us see what happens. So in this particular thing, we also have 5 nodes, 1, 2, 3, 4 and 5, and we have 1, 2, 3, 4, 5, 6, 7 and 8 number of edges here. So you can see that it basically doesn't correspond to a complete graph. It has a central node and it is connected to each of its nodes. Let me do it for 6 graph or 6 node graph. So here also we have a central node and it is connected to its n-1 nodes. So this is how a wheel graph works. Then we also have some random graphs present in Network X. So let me show you one instance of random graph, and we'll be using this random graph for our implementation in PageRank. So I'll just write G is equal to GNP underscore random dot underscore graph, and here I have first parameter as the total number of nodes. For example, I wrote 5, and then there is a parameter that is the probability of edge creation. Next parameter is the probability of edge creation. I just wrote 0.5. So with probability 0.5, it will make an edge between 2 nodes, and with probability 0.5 it will not make an edge between 2 nodes. So the probability is equal. So next, sorry, I didn't write nx here, that's why it is showing an error. So next I need to draw this particular graph. So you can see we have 5 nodes here and it has drawn the edges randomly. So let me draw it again, and it will show me a different graph because this is a random graph and it is making edges randomly. So let me draw it again. So see, now we have a completely different graph. So we'll be using this particular graph for our implementation of random walk method in PageRank. Thank you.